Hey guys, in this video we're going to talk about how to graph an exponential function. So I'm actually going to ignore all that stuff off to the right for now, so sorry it's there, but I did not feel like getting rid of it and making a new presentation, so this is the one I made for class. Anyways, we're just going to be talking about graphing though, and then in another video you'll talk about all the graphical features, identifying them, because I think it'll be easier to keep it separate for y'all. Hopefully that's easier for you. But we're just going to talk about graphing. So we are given a function here, and the function we are given is f of x is equal to 2 to the x power. Now, anytime I want to graph a function, basically what I do is I'm going to make a chart of values, or a table of values, and then I'll plot some points and follow along with the shape of the graph. So I'm going to go ahead and I'm going to make a table with my x and y values. And in order to figure out what points are on the graph, I'm going to have to pick a few x values. So what's important to consider when working with an exponential function is we talked about what exponential growth means, is that these functions grow really, really fast. So really, really quickly, they get really big. So you have to be careful when you choose x values to make sure that you're choosing x values where the y value will actually also be on the graph. So for instance, picking the number 6 would not be a wise choice for me here. Because if I were to plug the number 6 in for x, I would get 64. And I cannot plot the y value of 64 on this graph. So I'm going to want to pick a couple values that are actually relatively close to 0, just like slightly smaller values, so that I'm making sure that I don't have anything too crazy. What I like to do is always make sure you have at least one negative, one positive value, and plug in 0 as well. I want the exponent to be negative, I want the exponent to be 0, and I want the exponent to be positive. I'll clarify why I said that instead of just x in a moment. But in this case, okay, I'm going to go with -2, 0, and 2. Those are not the only values that would work here. You could go with a -3. You go with a -1. Sometimes if your values are all that close together, then it doesn't really show the shape of the graph that well, which is why I wouldn't really pick 3 consecutive numbers. But -2, 0, and 2 should be good. Again, -3, 0, and 3 would be fine. If you went with a -4, that would be fine. If you went with +4, you'd be talking about somewhere that's not on the graph anymore. So when it comes to actually plugging in these x values to get the y, remember all I'm doing is rewriting my function, but I'm going to plug in my x value now. So I rewrite the function exactly as is, but instead of x, I'm looking for f at -2. And that is going to be 2 to the -2 power. 2 to the -2 power. Thinking about properties of negative exponents, that is the same as 1 over 2 to the 2. Or in other words, 1 over 4. Okay. That simplified is 0.25. I'm actually going to write it in fraction form because to me that's a little easier to think about when I graph it. After I'm done with that, I'm going to find f of 0, or basically what is the value of the function when x is 0. So f of 0 would be, again, now 2 to the 0. Well, anything to the 0th power is 1. So I know that my answer there is going to be 1. And then my last point is x value is 2. So I'm plugging in 2. I have f of 2 equals 2 to the 2. And 2 to the 2 gives me 4. So that gives me my point. Now that I've finished filling in this table of values, and just for reference, always pick at least 3. But now that I've finished filling this table of values, I'm going to plot the points. Think of each of these x, y sets as a coordinate pair. So I could write this as like a little comma in between. Okay. But I had written in table form, but just showing you that that's essentially the same thing as just having points. I'm going to plot these. So for -2.25, I'm going to go to the x value of -2. I'm not going to be able to figure out exactly where 0.25 is, but basically that's only a quarter, so it's going to be pretty close to the x-axis, not that high up there. So the point is approximately where I just put it. For 0, 1, I'm looking at the x value of 0, y value of 1. That places me right here on the y-axis. And then I'm also going to plot to the point 2, 4. Okay. Now from here, I can basically go ahead and sketch my function. If you look at these 3 points and you're still not sure exactly how the function is going to look, go ahead and plot a couple extra points. Maybe pick x is -3 and x is 3, and those would give you another couple points, right? Like for instance, if I were to plug in 3 for x, I would have 2 to the 3. 2 to the third power gives me 8. So I would have the point 3, 8, right? So I could go ahead and I could plot that too if I wanted. Okay, but if you have 3 points on the graph and you picked them wisely, then you probably should be able to sketch the function just because we know what an exponential growth or decay looks like. So this is going to be an exponential growth because you can tell from left to right the points are increasing. And we know that an exponential growth, basically it starts really flat and then it gets really steep at the end. And you can sort of see this part where it's getting steep here. I can just sort of connect those and draw an arrow up there, just a rough sketch. When it comes to the bottom part where it gets really flat, sometimes, you kind of have to think about like, well, exactly where does it keep decreasing to? So in this case, if you're not sure, again, you can plug in another value. So like, let's say, what would the value be when I have an x value of -4? Well, if I raise 2 to the -4th power, that's the same as 1 over 2 to the 4, which is the same as 1 over 16. So think about this. When I was at -2, I was at 0.25. Now that I'm at -4, I'm at even less than that. So I'm even lower. Basically, these numbers are getting really, really close to 0. But it's not going to go past 0 because we kind of know that that is how exponential functions work. They like flatten out. So basically, it's just going to flatten out as it approaches 0 because no matter what I put in this exponent here, I could make it 2 to the -100. Well, that's just going to simplify to 1 over 2 to the 100. So it would just be 1 over a really, really big number. So all that's happening there is I'm approaching 0. I'm never going to get negative there because I don't have a -2 to start with. So no matter how far in the negatives my exponents go, I'm never quite going to get to 0. And that is how I sketch that graph. Okay. Now we're going to look at an example of a slightly more challenging graph. Let's go with this one. So what if I have a little bit of a transformation going on here? So the function that I'm given in this example is f of x equals 2 to the x plus 5. Well, if I want to graph that, I'm still going to make a table of values. But I'm going to have to think about those x values a little more carefully because if I did -2, 0, and -2, probably ain't going to work out great for me. So like I said before, I want my exponent to have a negative value, I want my exponent to equal 0, and I want my exponent to be a positive value. So what I'm going to do right now is I'm basically going to pick x values that I could plug in there to make my exponent negative, 0, and positive. And again, maybe I'm just going to sort of aim for that -2, 0, and +2. So in order to make that exponent -2, I would have to plug in an x value of -7. Okay. In order to make that exponent 0, I would have to plug in an x value of -5. And in order to make that exponent +2, I would need to put x as -3. So what I'm doing here is using those 3 x values. Okay. Again, I like to just sort of like look at how I can make the exponent a reasonable number because if the exponent gets really big, you're going to be way off the top of the graph or way off the bottom of the graph. Okay. Once I did that, I'm just going to go ahead and again plug it in. So I'll show this out certainly for the first one. So really I want f of -7. That is going to be equal to 2 to the -7 plus 5, or in other words, 2 to the -2, which gives me 1/4, or again, 0.25. Ooh. If I plug in -5 there, I'm not even going to write this because my computer's running out of battery, but if I plugged in -5, that exponent becomes 0, so I get an output of 1. And if I plugged in -3, we would have 2 to the -3 plus 5. That would equal 2 to the 2, or in other words, 4. I'm going to go ahead and plot those points. At -7, I'm very close to the x-axis. At -5, I'm at 1. And at -3, I am all the way up here at 4. So again, I'm going to just connect the dots basically, following the general shape of the function. And that would give me something that looks approximately like that. So hopefully this was helpful in graphing. And again, just remember, you're always probably going to want to try to make the exponent negative, make the exponent 0, and make the exponent positive.